Hey everybody, this is Mr. Charnetsky, and this is Unit 2.1, Lesson 2, Triangle Properties Continued. So the first property that we're going to look at is angle-side relationships within a triangle. And the biggest thing that we need to know is that the there's a relationship between an angle inside a triangle and the opposite side. And to demonstrate this, I've got a GeoGebra demonstration here. So here I've got an angle, and I can control the size of this angle using this toggle bar here. And here is the side that is opposite of it. So we got the two rays here, but across from our angle we have the side. And let's just take a look at what happens as we increase our angle size. Well, you can see as our angle gets bigger, the side across from an angle also gets bigger. Okay, you can think of it as kind of like opening a door. So the more you open the door, the bigger the space you can get through. So if you got a door just open just a tiny angle, then it's very hard to kind of squeeze through. But the bigger we open that angle, the bigger the angle, the bigger that side is across. And we can use that relationship to order our sides even if we don't know what the actual lengths are. If we know the angles, we know what relative size each of our sides are. So looking at this first example here, if I want to find the smallest side, what I want to find first is the smallest angle, which is going to be this 56 degree angle. That is our smallest angle, and that is going to be across from our smallest side. So the answer would be TS or ST, whichever order, doesn't matter. I can also use this to find the largest side. So if I found the largest angle, that's the largest. Across from that is our longest side, or largest. And then our medium angle, that's a medium, it's in between, is going to be directly across for the medium side. Let's take a look at another example here. This is asking us to find the same thing, the smallest side. One problem is we don't have all three angles, but we do have two angles, and we know from last time that all three angles have to add up to be 180. So if I take 180 and subtract 64 and subtract 55, I'm going to get my third angle there. So let's go ahead and do that. 180 minus 64 minus 55 equals 61. So that's 61 degrees. So that's gonna tell us that G is the smallest angle. So there's my smallest side, which is HI or IH, it doesn't matter. Okay. Again, they only asked us to find the smallest, but we could find the largest by identifying the largest angle. That would give us the largest side, or longest, as you could say. And then our medium angle. Ooh, I just made a mistake there, didn't I? That is not the smallest angle. 61 is not the smallest. That would be the medium. Not looking at my numbers carefully. Okay, 55 is the smallest. Across from that is going to be the smallest side. 61 is actually the medium. That's the medium side. So the correct answer is HG, not GH, or sorry, not IHI. So HG or GH be our smallest. Okay. What if they want us to do the reverse? They want us to find the smallest angle instead of the small side. Well, essentially we do the backwards. So we're going to look for the smallest side. So I got 12, 13, and 11. So this is the smallest side. And across from that is my smallest angle. So angle H would be my answer. Across from my longest side would be biggest angle. And across from the medium length side is my medium angle. Okay. The other property we're going to look at is mid-segments. Now, a mid-segment is made in a triangle if I connect two midpoints. So if I take a side, find the point that's halfway in between it, and connect it to the same on the other side, we get a mid-segment. And we can take a look at mid-segments in a triangle here. So here's a triangle. And a couple of things should stick out to us. First of all, a mid-segment, so DE is the mid-segment corresponding to AC. First thing you should notice is that they're parallel. Okay. The other thing that you should notice is that the mid-segment is half of the length of the side, of the corresponding side. So I color code in the green here. You can see that FD and CB, that's half the length, and it's parallel. And I can move things around here, and you can kind of see it. No matter what the shape, it still maintains that relationship. Now, for the most part, it's hard to see. There we go. These are rounded to the nearest decimal point, so sometimes they don't always match up, but they're just only because they're rounding. But we can still see it here. So 2.5 and 5. This is 5.7, half of 11.4. 4.5 is half of 9. So those are the two properties of mid-segments. They are parallel to their corresponding side, and they are half the length of our parallel side. Something you should note here also, maybe, when we do all three mid-segments, we essentially get 4 copies, 4 miniaturized copies of our big triangle. We get 4 smaller versions of it. All right, let's take a look at some problems here. So, the first question is asking, what is parallel, that's the symbol for parallel, to DE. So I'll just highlight that there. And the side that's going to be parallel to DE is going to be BC. So that's the corresponding side. Okay. The side that is parallel to FE. Then blue, well, that would be AB. And we'll just highlight the last two corresponding sides. So there's the mid segment belongs to AC. Okay, so next question is asking if AB is 14. So there's, oops, just let me write. Stop it. That's 14. It's asking what EF is. So remember the corresponding mid segment is half that length. So EF has got to be 7. Next question. Okay, it gives AE is 8. So remember mid segment, we make that by connecting midpoint. So if that's 8, that means that EC is also 8. And the entire length here is 16. And that means that DF is going to be half of that, so that is 8 as well. And the last question, DE, let's say is 6. So what is BC? Well, DE is half the length of BC. That means that this has got to be twice as much, so that's going to be 12. Okay. All right. Well, that's example question. So they asked us to solve for x. Now the key to this one is remembering that the mid segment is half the length of our corresponding side. Or in other words, we could say the reverse of that is it takes 2 of these to equal 1 of these. So when we set up our equation, we're not going to just set them equal to each other. That'll get us the wrong answer because they're not equal to each other. This is twice as big. So the way we're going to set this up is we'll set x plus 2 equal to, and remember it takes 2 of these. So 2 times 2x minus 14. And from here we can just distribute. Distribute that. So then we get x plus 2 equal to 4x minus 28. I'm going to subtract my x here. So that gives me 2 equal to 3x minus 28. Can add 28 to both sides. So that's 30 equal to 3x. Last thing I do is divide by 3. And so we get 10 equal to x. And that's the end of this video.